Hello everyone, welcome to the discussion session of tutorial 4. This is the last question, question 6 on excavation supported H-pile wall design. On this question, we are asked to design an excavation supported H-pile for the excavations up to 10-meter depth through a soil profile consisting of 0 to 5 meters of sand with phi equals to 34 degrees, gamma equals to 20 kilonewton per meter cube. Then for 5 to 15 meters of clay, which is soft, has an undrained shear strength of 50 kPa, gamma 21 kilonewton per meter cube. Below that, we have 15 meters of gravel. The area surrounding the excavation carries a live load on the surface averaging 50 kPa. We need to determine the lateral earth pressure distribution of a strutted H-pile wall using the following two methods: the equivalent height density method and equivalent pressure method, as in CFE-MEN. Finally, we need to provide a summary plot of the final apparent earth pressure determined from both methods and comment on the difference in the values. Which one is conservative, which one isn't, and why. So this is the figurative representation of the question, where this is the live load Q, 50 kPa coming from the top. This is the sand of 15 meters with clay of 10 meters, and below the bottom we have the gravel. We want to make the excavations on this side, where this is the HS, HC represent the height of the sand and the clay inside the excavation. So using the equivalent high density approach, we know the apparent earth pressure in sand, sigma A is equals to 0.65 gamma sand HES times Ka, where HES is the equivalent height of the sand layer, which we can easily determine using this equation, where Q is the surface live load, gamma is the unit weight of the sand, HS is the height of the sand layer. We can find the equivalent height of the clay layer, HEC, equals to this equation, and for that we need to also check the stability, gamma H over SU. If it is greater than 4, then it is soft to form clay. For very deep clay, the deposit is M equals to 0.4. So if we know the height of the clay layer, then we can find the apparent earth pressure in the clay using this equation. So this is a representation of a general representation of how is our apparent earth pressure distribution in the sand and the clay. And this is the final apparent earth pressure diagram. We need to find this coordinate that is creating this rectangular or square region within the sand and the clay. Secondly, on the equivalent pressure approach, we have the two steps. We need to first calculate the sigma V prime, then the sigma A, and finally the sigma apparent, which is 1.1 to 1.5 of the sigma A. Step 2 is finally draw the pressure distribution and find the area of the equivalent pressure. So one thing we should be keeping in mind, this height or this rectangular region within the sand is coming from the overburden surcharge, which we don't multiply with this apparent factor of 1.1 to 1.5. Rather, this distribution of within the sand and the clay with the height, we need to multiply with the apparent pressure factor of 1.1 to 1.5. Finally, our distribution should be like this, where we have the summation from the P1 and P2. And finally, for the clay, it's only P3. So we need to find this coordinate, and also we need to comment based on our lecture and the manual. So that's all for question 6. Thank you so much.